All right, this is going to be the last subunit for the unit of the solar system, I think it is. Um, this is other objects in the solar system. So the objectives are going to be to explore other objects in the solar system, distinguish between comets, asteroids, and meteoroids, and then furthermore compare and contrast meteors, meteorites, and meteoroids. And then we'll describe characteristics of dwarf planets, and finally examine the effects of Earth or on Earth from impacts by cosmic objects. So, what are asteroids? Asteroids are small rocky objects that orbit the sun. They're usually found in the belt between Mars and Jupiter. We've talked about that belt quite a bit now. So, an interesting fact is, as a group, all the asteroids in that belt between Mars and Jupiter weigh less than the moon. So, they're generally very small pieces of rock. They vary in size from about 1 kilometer to 900 kilometers across. In the general scheme of things, that's pretty small. So, the Earth is 12,800 kilometers. That's, quite a bit larger than most of these asteroids. And most of the asteroids are about 1 kilometer. They're very small. They have irregular shapes due to constant impacts. They're just rotating around the sun, smashing into stuff all the time. And that's why there's so many of them, and that's why there's so many small ones. Because if you just keep getting smashed, you're going to get smaller and smaller and create more. They have many craters, also due to impacts. Ceres was an asteroid in the belt between Mars and Jupiter, but we've now classified it as a dwarf planet. And we'll get into what dwarf planets are. And so here you can see right here between Mars and Jupiter is that asteroid belt. Goes all the way around. And then here's a really close look of the asteroid belt. And here's Ceres in it. So it's huge compared to all the other asteroids. I mean, look at that thing. So, comets, what are they? They're very small objects made of ice and dust that orbit the sun. They form a coma a comma, no, it's coma, as they approach the sun. They have very elliptical orbits. So if you look at my mouse, they go like this kind of. It's not a circle. They go really, really far away from the sun. Say this is the sun. They'll orbit it pretty close, and then they'll go really far away, and then they'll come back, and they'll get kind of close, and then they'll go really far away again, and then they'll come close again. It's kind of like a boomerang, where it's just like not completely circular. So they're often described as dirty snowballs because of that ice and dust. The center of a comet is called a nucleus, and a comma is a cloud-like structure around the nucleus. So it's kind of like the tip of a ballpoint pen, kind of. It forms due to the heat from the sun, and so it's kind of like the head of the comet. Really, all it is just all that ice and dust being vaporized and then like falling backwards behind the comet and around that nucleus. And then they have tails. So their tails are just dust and gas. They're formed with the heat from the sun, and they generally have two tails, so they kind of split off behind the head. Imagine if something's like coming towards me, and then it hits and it goes back. So my head would be the coma or comma, and then inside my brain would be the nucleus. It's kind of a weird way of thinking about it, but just made that up. So here we go. This is the coma or comma, and right back here we've got two tails separating. You can see it pretty clearly how they just separate away. And this will be like many, many, many miles, thousands of miles. You'll see that tail. So, what are meteoroids? Meteoroids are small chunks of rock and debris in space. They're typically very, very small. We're talking about like a grain of sand most of the time. Sometimes they can get up to a large boulder. That's not very often because they're just kind of floating around, smashing into stuff, so that makes it very small. Their composition varies greatly depending on the source, so where it came from, what celestial body it came from. If it came from Mars, you're going to see a lot of iron in it. If it came from, somewhere like Neptune or something, you're going to see a lot of methane inside of it, that type of stuff. So the orbit and speed varies depending on size, the distance from its sun, how many impacts it's having, all sorts of stuff like gravitational pulls. Their orbit and speed varies greatly, so it's kind of hard to give you a constant on that. Then go ahead and pause it here. Try and take my face out of here. I'll put it like right here. And then just look at meteoroids versus asteroids. So, asteroids hitting the Earth is pretty bad because they're humongous. Meteoroid, will turn into a meteorite and then hit the Earth. And generally, they're not very devastating. So, like, you know, they're a lot smaller compared to a large asteroid. So, what is a meteor? A meteor is a meteoroid that enters the atmosphere and burns up, which produces a streak of light in the sky, which is going to be kind of like that comet, you know, producing vapor. And that's what shooting stars are. So, the next time you see a shooting star, you know, the idiom "thank your lucky stars" is going to apply very well for that one, because you better be thanking your lucky stars that that didn't hit the Earth, because that's going to cause a severe impact. So keep being happy that you're seeing shooting stars, because that's just objects coming from space that are burning up in our atmosphere before they hit the Earth. So they're moving extremely fast. So that friction between the object and the gases in our atmosphere, we talked about how the atmosphere is what kind of like stops collisions from happening on Earth. That's going to cause the object to disintegrate. So it's that friction. So remember that friction is a force that happens, because we're going to be talking about friction a little later. Not in this unit though. And then what are meteorites? So we've got meteors, meteoroids, and meteorites. Meteorites are meteors that strike the Earth's surface. So meteorites are just able to get through that atmosphere and hit our surface. So we've got the meteoroid in the atmosphere here, or in space, excuse me. Got a meteoroid in space. We've got a meteor in the atmosphere. They burn up. If they don't burn up and they strike the Earth, you got a meteorite. All right, so take a picture of this, you know, take some notes, whatever. This is going to be on the quiz. So what are dwarf planets? They're essentially just round objects that orbit the sun that lack the ability to clear the neighborhood around its orbit. So there are three distinguishing characteristics of dwarf planets. They're round, they orbit the sun, and they lack the ability to clear the neighborhood around their orbits. So our dwarf planets that are kind of like the most famous ones, especially the most observable ones, are Eris, Pluto, poor Pluto used to be a planet, Haumea, Ceres, and Makemake. So they share zones of orbit with other objects, and that's why they lack the ability to clear the neighborhood around its orbit. So when they're orbiting, there are other things also orbiting around with them, and they're unable to clear that orbital zone. So here's just the dwarf planets in our solar system. This isn't even all of them in our solar system. These are just the ones that like are pretty observable in our known solar system. So there are a bunch in the Kuiper Belt, which we'll talk about later. So here's poor little Pluto. And then look, most of these were discovered between 2003 and 2005. Ceres is a pretty easy one to see because it's in our asteroid belt. But these ones, most of these ones are in the Kuiper Belt. So they're technically considered trans-Neptunian objects, TNOs. So beyond Neptune, the Kuiper Belt, that's going to be the location of most dwarf planets, the ones that we know of here other than Ceres. And there are plenty of other ones I'm sure that we just haven't found yet. So they're going to be the location of many trans-Neptunian objects, or TNOs. That's where the Kuiper Belt is. It's around 30 to 55 astronomical units away from the sun, and it contains thousands of undiscovered objects. So we've only just begun to explore this region because it's just so far away. We haven't had the technology or the time to be able to just like send a probe out into space and get readings back. It takes a long time for that stuff to get out there. So here's just a bunch of trans-Neptunian objects. You can see, you know, we've got whatever that is, Quaoar, Sedna, Orcus, 2002 MS4, Salacia. All of these are new trans-Neptunian objects that we could not find yet, or that we have found that we could not find previously. And then these ones are the ones we talked about, except for 2007 OR10. So here's the Kuiper Belt. This is Neptune. So this is the 8th planet here. This elliptical pattern is going to be Pluto. And then we've got another one for Aries, I believe, that goes way out. So let's talk about impacts on Earth. Impacts on Earth are just collisions with large objects many kilometers across. So to impact is to make contact forcefully. So, you know, when you punch somebody, you're making an impact on their face. Don't do that. It results in major devastating changes to life on Earth. So we have 5 major impacts known. to science. There could be more, but we know of 5. We have evidence for 5. The most recent was around 65 million years ago, and that is just so happens to be the time when all of the dinosaurs went extinct and mammals started becoming the dominant species on Earth. So they're indicated by mass extinctions or geological events. You know, that's the geologic timescale right there, why we have it. So 50 to 96% of life on Earth went extinct. So we've come close quite a few times to just having no life on this planet. So being a human today is a great gift. So you know, use it up. Live life. So their effects on Earth. What are their effects on Earth? Impacts. We've got massive dust clouds. So you know, when it smashes the Earth, a bunch of dust is going to go into the air and the atmosphere, and that's going to block out the sun. It's going to stop plant growth. It's going to make it very cold. You know, we'll see some ice age action going on. And then we're going to see flash fires, which is going to contribute to ash in the sky, which is going to also block out the sun. And we're going to see a change in average temperature very, very quickly. We're going to see mass extinction events and change in the distribution of life forms. So 65 million years ago, we saw a change in the distribution of life forms from dinosaurs to mammals. And we see this in our fossil record. 65 million years ago, we had dinosaurs. A million years later, we didn't. A million years later, we had mammals. So we saw this change in our fossil record and change in dominant species of life. So, and this is generally because mammals were very small. They were hiding in like holes and stuff. They have fur, so you know they're able to withstand cold temperatures. They weren't severely impacted by that impact from the meteor or meteorite hitting the ground. So mammals were just lucky, and we're mammals. So we have evidence of impacts on Earth. As I was talking about, we have evidence of those 5. There could have been more, but we have evidence of 5. So the evidence is that sudden change in the fossil record. You know, dinosaurs stop and mammals start. That's pretty clear. That's that geologic time scale that we talked about in Earth Science A, I believe. Rare minerals, only typically found in celestial bodies, are found in dust layers. So like iridium, this generally doesn't happen. I don't think this occurs at all on Earth naturally, actually. So when we find this, we know that we got it from some sort of impact from space. Then we've got layers of burned organic material, which signified major fires. And this was like extreme large amounts of layers of burned organic material. And this is layers way deep down under the ground, like, you know, 65 million year old layers. So we've got temperature changes shown in the ice core records as well. And then there's massive craters, and that's just the most obvious one. We see a massive crater, and we start doing some investigative work around it and find out, like, oh, hey, this was an extinction event here. And so here's just a really good view of a massive crater in Arizona. This one didn't actually cause an extinction event, but you know, you can imagine this is huge. This is many kilometers across, hitting the Earth at about 26,000 kilometers per second. So that's extremely fast. And then here is just a picture of all of the meteorite strikes that we've seen on Earth, or that we have evidence of on Earth. And this one right here in the Gulf of Mexico, that's going to be the one that killed the dinosaurs. Yeah. So this is the bad boy right here. But, you know, as you can tell, we've had plenty of them, but we've only been able to correlate 5 mass extinction events to impacts. I think this was one, probably this one. So that's all you're going to need to know for the quiz and the test. Go ahead and let me know if you have any questions, comments, or concerns. Otherwise, have a wonderful week.